Hi, welcome to our channel of IGNOU audiobooks, Indira Gandhi National Open University, School of Social Sciences, SOSS. Master's Degree Programs. Master of Arts, Economics, MEC First Year. MEC-001 Microeconomic Analysis. Block-1 Consumer Behavior. Unit-1 Theory of Consumer Behavior, Basic Themes. 1.0 Objectives. The objective of this unit is to relate how individual consumers take decisions of consumption in a situation where market prices are given to them and they can't influence the market prices by altering their consumption. This unit will enable you to determine the optimum choice of a consumer. Explain how the price effect can be decomposed into income effect and substitution effect, and determine the individual demand curve. 1.1 Introduction. It is generally observed that market aggregate demand curve for a commodity is downward sloping, given other things. Our problem is to investigate economic rationality behind this for a commodity of all individual consumers. The market demand basically depends on the characteristics of demand for a commodity by individual consumers, and the demand for a commodity of an individual consumer depends upon the behavior of the consumer. Clearly, to investigate economic rationality behind the law of demand, we shall start with the analysis of consumer behavior. 1.2 The Basic Themes. There are different approaches to analyze the consumer behavior, but in all approaches, it is assumed that the consumer is rational. This means that the consumer's objective is to maximize her utility by choosing one commodity bundle from among all the commodity bundles. Money, income, and the prices of the commodities are given to the consumer. 1.3 Consumer choice concerning utility. Consumers can't maximize her utility unless she can measure it. Hence, utility must be a measurable concept. The measurement is undertaken differently in different approaches. In traditional frame, we have two types of measurement of utility. 1. Cardinal analysis. 2. Ordinal analysis. 1.3.1 Cardinal theory, an introduction. In cardinal approach, utility is measured cardinally or numerically in terms of money. The consumer not only knows which one is preferred but also by what amount. The assumptions of this approach is given below. 1. Consumer is rational. Implication: the consumer's objective is to maximize her utility by choosing one of the commodity bundle from all other available commodity bundles at given prices of commodities and money, income. 2. If the taste and preferences are given, the total utility of the consumer depends on the quantity of consumption. 3. Goods are good. Implication: let U denote utility level of the consumer and let X be the consumption bundle. As X increases, decreases, U increases, decreases. Therefore, marginal utility is positive. 4. Marginal utility of X is diminishing. Implication: as X increases, decreases, MUX decreases, increases. Therefore, MUX curve is downward sloping. 5. Utility is measured cardinally or numerically in terms of money. Implication: since it is measured numerically, consumer not only knows which commodity bundle is preferred but also by how much amount. 6. Marginal utility of money is constant. Implication: MUM equals lambda, where lambda is positive and constant. That means as money income increases, decreases by 1 unit, utility increases, decreases by lambda unit. Consumer equilibrium. According to our assumption for X units consumption of the commodity, gross utility obtained by the consumer is Ux. But for this, the consumer must spend Px, X units of money income if Px be the price of the commodity X, which is given to the consumer. Since from assumption 6, lambda represents fall in utility due to 1 unit fall in money income, the net utility of the consumer is given by nx equals ux, lambda px, x, where lambda and px are given to the consumer. So consumer's objective is to maximize nx by choosing x. For that we take the first derivative of nx and set that equal to 0. dnx upon dx equals 0, or we get dx upon dx minus lambda pz equals 0. 1.3.2 Ordinal theory. A short note in ordinal approach, utility is measured ordinally i.e., qualitatively, not numerically or quantitatively. Alternatively, consumer can rank her preferences according to the order she wants to compare but not in terms of the different amount. It's a qualitative measure and therefore more realistic measurement of utility or satisfaction. There are two different approaches of ordinal theory, viz. 1. Indifference curve approach. 2. Revealed preference approach. 1.3.2.1 Indifference curve approach. Indifference curve is constructed by taking utility level constant, so different indifference curves imply different level of utility for same consumer. The equilibrium is achieved when indifference curve become tangent to the budget line. 1.3.2.2 Revealed preference approach. In revealed preference approach, consumer equilibrium can be found by ranking different bundle of goods in the commodity space. Given the budget constraint, consumer chooses the best bundle for which her utility will maximize. This theory was originally constructed by the famous economist Paul A. Samuelson. 1.4 Introduction to demand analysis. It is generally seen that market demand curve is downward sloping. Market demand curve, or sometimes called aggregate demand curve, is nothing but the aggregation of individual demand curves. Individual demand curve can be constructed by joining different consumer equilibrium for different prices. Remember that consumer can't alter the market prices. It is given to the consumer. In neoclassical consumer theory, price is exogenous variable, so demand curve can be obtained only if we change the price exogenously and join all the equilibrium points. From next on, our objective is to find out the consumer demand curve, for which we will adopt ordinal theory, and in that we will take indifference curve approach. 1.5 Ordinal theory. Indifference curve approach. In indifference curve approach, consumer is assumed to be rational, so that consumer's objective is to maximize her utility by choosing a commodity bundle among all other available commodity bundles under budget constraint, where total utility U depends on quantity consumption given her taste and preferences. Therefore, in a two-commodity world, say x1 and x2, utility function is given by U equals U, x1, x2, and it depends on taste and preferences of the consumer, which is specified by axioms given below. 1. Axiom of reflexiveness. Consumer's choice is reflexive. Implication. Weak preference relation is denoted by R. Suppose there are two goods x1 and x2 and suppose x1 is weakly preferred to x2 i.e., x1 or x2, which implies that either x1 is strictly preferred over x2, it is denoted by x1 px2, or x1 is indifference to x2, it is denoted by x1 x2, where p and I imply strict preference relation and indifference respectively. The set constituted by all commodity bundles or vector is known as commodity set X. Any one commodity bundle is denoted by X is weakly preferred, i.e., either strictly preferred or indifferent, over any other commodity bundle, i.e., in respect to X. Therefore, we have X, Rx. Clearly, any one commodity bundle may be indifferent to another commodity bundle, i.e., there is a possibility of indifference or same level of utility between the commodity bundles. None of the commodity bundles are not preferred, i.e., consumer can choose any commodity bundle So choice set of this consumer is specified by the commodity set X. 2. Axiom of completeness. Consumer's choice is complete. Implication: since consumer is rational, she must have a unique preference. Relation: that means the consumer choice is either X1 or X2 or X2 or X1. Alternatively, consumer's choice is consistent or comparable. For unique preference relation, consumer choice must be transitive, where transitivity implies that if X1 or X2 and X2 or X3, then X1 or X3, where X3 is another commodity. 3. Axiom of continuity. Consumer's preference relation, R, is continuous. 1. Axiom of non-satiation. Consumer's choice is non-satiated in all goods. Implication: non-satiation means larger the consumption of a good leads to larger satisfaction or utility, or lower the consumption, lower is the satisfaction or utility. Non-satiation of all goods, which means goods are good or more is better, means any commodity bundle A is preferred over another commodity bundle B only if bundle A consists larger quantity of at least one good and no less quantity of any other goods. Notationally, if A greater than B, then A is preferred over B or APB, where B is any other commodity bundle. 2. Axiom of convexity. Consumer choice is such that indifference curve is strictly convex to the origin, i.e., utility function is quasi-concave. 3. Axiom of selfishness. Consumer choice is selfish. Implication: consumer's choice is self-guided. It is not influenced by any other consumer. 1.5.1 Concept of preference, utility function, and indifference curve. Consumer preference, R, specified by the above axioms, can be represented by a function where total utility, U, depends on quantity consumption, X1, X2, which satisfied all other axioms. The function U equals Ux1, X2, is known as utility function. Since consumer is rational, her objective is to maximize the utility specified by the utility function U equals Ux1, X2, subject to her budget constraint. To solve the consumer utility maximization problem, we use a graphical tool, which is known as indifference curve. Meaning and definition of indifference curve: different combination of goods X1 and X2 along which consumer is indifferent, or consumer has same level of utility, give a curve in commodity plane known as indifference curve. Therefore, along the indifference curve, utility or satisfaction remains unchanged. Existence of indifference curve: because of axiom of reflexiveness, consumer can choose a commodity bundle over another commodity bundle, i.e., consumer may be indifferent between any commodity bundle and such a choice might be continuous. So, indifference curve may exist anywhere in the commodity space. 1.5.2 Derivation of indifference curve. Consider any commodity bundle denoted by point A in the above figure, which consists X0, 1 and X0, 2 amount of good I and good 2 respectively, and from which consumer obtains particular level of utility, say U0. We compare the commodity bundle A with the other commodity bundle in the commodity space. For that we divide the entire commodity plane into 4 phases from A. Consider any point in phase I, say beta, where we have large quantity of both X1 and X2 compared to point A. Again, if we consider any point, say A, in horizontal line in phase I, we have larger quantity of X1 with same quantity of X2 compared to point A. Similarly, for any point B in vertical axis, we have larger X2 with same X1. That means in phase I, including the borderlines, we have larger quantity of at least one commodity and no less quantity of any other commodity compared to A. Thus, we have larger utility in phase I including the borderlines compared to A. By similar logic, we have lower consumption of at least one good and no larger consumption of any other good in phase 3 including the borderlines compared to point A. Hence, we have lower level of utility in phase 3 including the borderlines compared to A by the axiom of non-satiation for all goods. Clearly, in phases 1 and 3, including borderlines, utility is not constant between the commodity bundles compared to point A. So, indifference curve, along which utility is constant, can't pass through phases 1 and 3 including their borderlines. Consider any point in phase 4 excluding borderlines, say alpha. We have larger x1, for which utility is larger, and lower x2, for which utility is lower, compared to A. Since both goods are non-satiated, utility of point alpha may be larger, lower or equal compared to point A. Similarly, for any point in phase 2 excluding the borderlines, say delta, we have larger consumption of x2 but lower of x1 compared to point A. Therefore, by axiom of non-satiation in all goods, utility at point delta may be larger, lower or equal compared to A. Clearly, only in phases 2 and 4 excluding the borderlines, there is a possibility of the same level of utility between the bundles compared to point A. So, indifference curve, along which utility remains unchanged, must pass through the phase 2 and phase 4, excluding their lines. Thus, indifference curve is necessarily downward sloping where all goods are non-satiated given that a consumer choice is continuous, reflexive and complete. Economic meaning all goods are non-satiated i.e., larger, lower, consumption leads to larger, lower, utility. Hence, for given x2, as x1 increases, utility increases. Thus, to maintain same level, utility must be reduced, which is possible by reducing x2. Hence, as x1 increases, x2 must decreases in order to maintain same level of utility. That is why indifference curve is downward sloping. Properties of indifference curve. Property I. Higher indifference curve gives higher utility. 1.5.5 Slutsky's theorem at initial prices and money income. Budget line is abundant according to the condition of the equilibrium. E0 is the initial equilibrium point. The consumer gets U0 level of utility. Suppose at constant income and P2, P1 decreases, say by 1 unit. Consequently, the intercept of the budget line, M/P2, remains unchanged but absolute slope of the budget line, P1/P2, decreases. The new budget line becomes flatter with the same intercept. It is denoted by AC line. New equilibrium can be achieved at any point on the new budget line AC, and therefore own price effect can take any algebraic sign. Suppose the equilibrium takes place at point E1. Hence, as P1 decreases, for given P2 and M, demand for good increases from x1 power 0 to x1 power 1. This is the own price effect for x1. And here it is negative. A part of this change is due to change in real income. Since for given P2 and M as P1 decreases, real income increases, and another part is originated at constant real income. To decompose these effects, we reduce money income, M, of the consumer in such a way that real income in terms of utility remains unchanged. After such reduction of M, intercept of the new budget line AC, i.e., M/P2, decreases with the same slope, P1/P2, for given P1 and P2. Hence the new budget line shifts parallelly downward subject to the fact that after the shift, it is tangent to the previous indifference curve. The consumer can attain the same level of utility and the real income remains constant in terms of utility after adjusting money income, and utility is also maximized. After adjustment of money income, budget line is ACK along which real income in terms of utility remains constant after change in P1 for given P2. This budget line is known as compensated budget line. Under such budget line, equilibrium will necessarily take place at point T1. Hence, under constant real income in terms of utility, as P1 decreases for given P2, x1 increases from x1 power 0 to x1 by substituting x2 from x2 power 0 to x2 power 1. This is known as own price substitution effect for x1, which is negative, and indifference curve is downward sloping strictly convex to the origin. But as x1 increases from x1 power 0 to x1 power 1 and real income also increases, the demand for good I increases from x1 power 0 to x1 through a rise in real income. This would indicate that by income effect for a price change, x1 is a normal good. Clearly, we have own price effect consists of own substitution effect and income effect for a price change, where own substitution effect in negative but income effect for a price change can take any algebraical sign depending on the good is normal, superior or inferior. 1.5.6 Compensated demand curve. Compensated demand function for a commodity, say x1, of an individual consumer represents demand quantity for that good, which is purchased by the consumer as a function of price of that good and prices of other goods, under constant real income and constant other things. Notationally, it is given by x1 equals x1 p1, p2, y, where y is the real income demand curve for a good, showing the relationship between demand quantity for that good and its own price given other things and given real income is known as compensated demand curve, along which real income is constant. Real income is defined by the ratio between money income and price level. Along the demand curve, price of that good changes, so money income should be proportionately adjusted or compensated such that real income is constant. That is why the corresponding demand function and demand curve is known as compensated demand function and compensated demand curve. There are two different approaches to the measurement of real income, viz. Hicks's approach. In Hicks's approach, real income is measured in forms of utility. A constant real income means a constant utility. Thus, demand quantity for a good purchased by a consumer as a function of prices of all goods under constant utility and constant other things is known as compensated Hicks's demand function. Demand curve for a commodity showing the relationship between quantity demand for that commodity and its own price under constant other things and constant real income in terms of utility is known as compensated Hicks's demand curve. Slutsky's approach. In this approach, real income is measured in terms of purchasing power. A constant real income means a constant purchasing power. It is denoted by EP. Demand quantity for a good purchased by a consumer as a function of prices of all goods under constant other things and constant purchasing power is known as compensated Slutsky's demand function, and corresponding demand curve is known as compensated Slutsky's demand curve. Below we discuss the Hicks's approach graphically. Derivation of compensated demand curve. Hicks's compensated demand function for x1 is given by x1 equals x1 p1, p2, u, where Hicks's compensated demand curve for a good represent the relationship between price of that good with its own demand quantity for given prices of other goods and real income in terms of utility. We now derive this graphically. Suppose initial equilibrium is attained at E0 in figure A, where price of good 1 is P1 power 0 and price of good 2 is P2 power 0 respectively, and utility is fixed at U0. Corresponding indifference curve is IC0. Compensated Hicks's demand for x1 is at x1 power 0. Expenditure line is up at initial equilibrium with absolute slope P10/P20. Plot this x1 power 0 and p1 power 0 in figure B. Suppose, for given utility and P2, P1 decreases to P1 power 1. Therefore, absolute slope of the budget line decreases, i.e., expenditure line become flatter. Since utility is constant, the indifference curve remains the same as before. Therefore, expenditure is minimized for given utility at point E1 in figure A, as indifference curve is downward sloping strictly convex to the origin. So compensated Hicksian demand for good increases to x1 power 1 plot p1 power 1 and x1 power 1 in figure B. By joining all such pair of p1 and x1 in figure B, we have a downward sloping curve in p1 x1 plane for given p2 and utility. This downward sloping demand curve is the Hicksian compensated demand curve. This is shown in the above figure B. 1.6 Let us sum up. In this unit, we discussed various aspects of consumer behavior theory. We elaborated two classical theories, viz. Cardinal approach and ordinal approach. In ordinal approach discussing the indifference curve theory, we show that indifference curve in general is downward sloping and strictly convex to the origin. Consumer equilibrium in ordinal approach was found out both graphically and algebraically.
In the ordinal approach, at equilibrium, two condition must satisfied. The first condition is the equality between slope of the indifference curve and slope of the budget line, which indicates that at equilibrium slope of the budget line must be equal to slope of the indifference curve. The second condition shows that at equilibrium budget constraint must satisfy with equality sign, i.e., consumer spends all her income in consumption. This condition is derived from the assumption of non-satiation of all goods. The income effect and substitution effect have been presented and meanings explained. An income effect is the change in consumer demand due to unit change in income when other things are held constant, and substitution effect is the change in consumer demand due to change in prices of any one good, the utility and other things remaining unchanged. In the next section, we discussed the Slutsky's theorem, which is the relationship between price effect, income effect and substitution effect. It shows that price effect is the sum of substitution effect and income effect. Finally, we discussed the compensated demand curve analysis derived by Hicks. Thank you. Subscribe to our channel for more updates, and we will see you with the next chapter.